there is a very interesting, I guess, phenomenon that happens: Clathrate Hydrates. So this is a Clathrate Hydrate, and it looks very much like kind of a weird rock or a chunk of ice, but chemically it's not that. It's very interesting. Basically, what it is it's a cage of water molecules surrounding a gas molecule. If you look here, the blue with black lines connecting it is a water molecule, hydrogen bonded together, and that blue ball there is some sort of gas. Basically, the water molecules, again due to hydrogen bonding, will just form this cage around the gas molecule, essentially trapping it. Now, it's not true ice, and it's also not a chemical compound with the gas and the water, because the gas is not bonded to the water, it's just trapped in the water. And it's also not ice because it's not technically frozen water, it's just a crystalline structure surrounding a gas molecule. Now, these can be found in varying locations, very commonly at the bottom of the ocean, as well as the depths of Lake Baikal, because there's always fucking something with that lake. And one of the most common gases that are actually trapped within these Clathrate hydrates is methane, a very strong greenhouse gas. And it's being studied currently to actually use these clathrates as a potential energy source because of specifically the methane stored. It can potentially be a very good, somewhat renewable energy source. However, the trapped methane has been used... There's a really big fucking bug outside. Cool. There has been a hypothesis developed called the Clathrate gun hypothesis, and this is specifically because of the large amount of methane stored within these clathrates. Clathrate gun hypothesis has been used to kind of explain a period of rapid global warming during the Quaternate period, which was about 2.58 million years ago. During that time, the planet very quickly got a lot warmer. A proposed explanation for why that happened is the Clathrate gun hypothesis. So basically, the hypothesis is that a lot of these clathrates were kind of not dissolved, but they kind of broke apart, releasing a shit ton of methane into the atmosphere out of the bottom of the ocean. So when clathrates form, they're kind of stabilized and kept in this form by either very low temperatures or very high pressures. When either of those change, the clathrates kind of just pop and release all the gas, and the water molecules form back into regular water, and the gas is released to do whatever that gas wants to do. So when a large amount of these, specifically containing greenhouse gases like methane, are released at one time, it just kind of gets released into the atmosphere and causes a runaway climate change greenhouse effect. Now, currently, with our current climate change, it's not thought that clathrates are really responsible for that. It was hypothesized that it was responsible for some past massive climate changes, but currently people don't think that they're actually that much of a concern in this right now climate change. However, with the current climate change that is happening, everything is gradually getting warmer, and there could be some potential future risks from the clathrate deposits in the Arctic. There are a great number of shallower clathrate deposits, which are stabled rather than by the pressure by temperature, and with the overall warming, that temperature could decrease, eventually releasing the methane stored in those deposits because it's simply not cold enough to keep them solid anymore, and that could cause a whole runaway effect where it gets warmer, so it releases the methane, which causes it to get warmer, which releases more, and a whole feedback loop that we don't want. So currently, they're not an issue, but potentially they could be.